So recently I have come across with a problem which has interested me a lot. So here it is the problem. R2 plane, suppose in the R2 plane if we draw n lines such that now two lines are parallel and now three of them meet at a point. The question is into how many regions do they divide the plane? So let us say what the question means. Suppose I say n equals 1. That is, we are drawing one line in the R2 plane. So let this be the R2 plane, and if we draw one line, say this is the line, it divides the plane into this region and this region. So when n equals 1, the R2 plane gets divided into 2. We don't have to draw the x-axis or y-axis. It's just a plane. If we draw a line, it divides the plane into, say this goes like, it is not just a bounded plane. So it just divides the plane into two regions. So when n equals 2, we have two lines in our hand, and the condition says these two lines cannot be parallel, and no three lines. We do not have three lines, so we'll worry about that later. So here is one line, I'm drawing another line which is not parallel. So what happens is we divide the region into four parts, four regions. So we got n equals 1, say the regions are 2, and if n equals 2, number of lines, we divide R2 into four regions. So what happens when n equals 3? So we can't draw any line parallel to this line, so that line is not possible, and it cannot intersect each other like at a single point. So let us say we draw like this. So this line satisfies all the conditions. So we'll count the number of regions. So let's say this is first region. Okay, now this is second region, third, fourth, fifth, sixth, and there is a small region here. So n equals 3, we get 7. So what happens when, say, for an arbitrary n, so how many regions do they divide the plane? So that is the question. So to solve this question, let's say we define a function f. So what this function is like f maps from the number of lines, say n. So if we get n equals 1, which means if we get one line and the image, say the number of regions, it divides the R2, the number of regions into which R2 get divided. So it is say m, it's a number of regions, whatever it is. So we got f of 1 equals 2 and f of 2 equals 4 and f of 3 equals 7. So we want to find what is f of 4. Similarly for an arbitrary n. So this is clearly a function. Let us say what will be this value. What we note here is, suppose we have an empty plane, and if we draw one line, it doesn't touch any other line because we don't have any other line. Suppose I am adding another line to this plane, since due to the condition we say the next line cannot be parallel, so it will touch at one point, and if we add another line, it should not be parallel or it should not touch the intersection. So it will touch 2 points. So what we get is if we have k lines, say we have k lines in the plane, this need not be parallel, and if we add k plus 1 line to the plane which is neither parallel or all these conditions which we have stated above, so it touches the k plus 1th line. Say we call this line as k plus 1th line touch exactly k points. This is what we have to note. We touches 1, 2, 3 and exactly k points. We can see that since none of these are parallel or neither, we do not have any like common point of intersection. So this is something we have to note. What another interesting thing is that since the k plus 1th line touches at k points, say this line is coming from here, this k plus 1th line, and it touches the first point at some line, so it touched one plane just before this intersection point. Then next, when it touched the next line, say second line, it goes to the second plane, second region to be specific. Similarly, it goes on like say here, and the last line, say kth line. So here it is. What we can see that if we touch k points, this k plus 1, this line, it goes through exactly 1, 2, 3, that means k plus 1 regions, right? Can you see that? It goes from here, the first region, second region, so this is first, second, third, so it goes to k plus 1 regions. Say we'll draw this line, say here. So what happens if this line goes as it goes through these planes? What happens is it divides these k plus 1 regions into two, such that this first region it divides into two regions, the second one two. So total number of new regions obtained is 2 times k plus 1 as of the old. So we can observe an interesting fact from here. Suppose say f of k plus 1. What is the relation between f with f of k? We have to find the relationship between these two. So what it does, it changes the k regions, that k plus 1 regions, and makes into 2. So we cannot just add just like 2 times k plus 1, because we already had this k plus 1 region, so we can subtract it. So this would be the relation with f of k plus 1 and f of k. So if we solve it, it looks like f of k plus 1. So if we write as say f of n, we can write as f of n minus 1 plus n. So we get the formula. So we can put it here instead of question mark. F of n is, let's wrap this off. F of n is f of n minus 1 plus n. Now this is interesting. So we can substitute this n minus 1 as f of n minus 2 plus n minus 1, and together with this n. Similarly, it goes on below. So finally we can get f of 1. It will be the last term. This f of 1 body came from f of 2 equals f of 1 plus 2. So the next term will be 2. The next term will be 3, 4, etc. n. So what it says is f of 1. Oh, we know f of 1 is 2. So instead of f of 1, we can write 2 plus this term. So we can split this 2 into, we don't want this, we can split this 2 as 1 plus 1 plus 2 plus 3 plus etc. n. So it gives like 1 plus the sum of first 10 terms, which is n plus n into n by 2. You know what I'm talking about. So we get the formula is the number of regions are to get divided into. If we draw n lines, we get the number of regions as 1 plus n into n plus 1 times n plus 1 divided by 2. So this is the answer we have been looking for.